This section talks all about exponents. Exponents indicate repeated multiplication. It provides a more complex way to write expanded factors. Here in this first example, 5 cubed can also be written as 5 times 5 times 5. Or 3 to the 5th represents 3 multiplied by itself 5 times. The same thing is true for variables. X cubed indicates x times x times x. On a special note, negative 5 squared with the parentheses around the negative 5 would indicate negative 5 times negative 5. In contrast to that, negative 5 squared indicates multiply the 5's together first and then perform the negative. This is referring to order of operations. The negative 1 in front is multiplication. It's multiplying by negative 1. So we have to do the exponent first, then multiply by the negative. You'll notice that you'll get two different answers then for these two problems. A calculator knows how to do this, but just keep in mind if you check your answers, it's important where those parentheses go. We can also do the reverse and actually change it from a more compact form to a more expanded form. Here are some examples of that. 3 times x can be written as 3x squared. 2 times 5 times x times x times x equals 10x cubed. And finally, 7 times a times a times a times b could be written as 7a cubed times b squared. What we're going to practice is actually combining similar terms. Anytime you have exponents that are to the same exponent, you can combine them together. So this first one, every single term is an x squared. So all of them can be combined together. I have 4 of them, another 7, and then a negative 2. Altogether, this is 9x squared. The second one, there are different letters, so I'll need to keep track. I have negative 8x cubes and 4 more of them. That gives me negative 4x squared. And then I have 9y squared and a negative 11y squared, or negative 2y squared. For this next one, I can combine together the x squareds, but I'll need to do the x's separately. Those are not like terms. They have to match exactly with variable and exponent to be considered alike. So I have negative 4x squareds in total, and negative 5x's in total for the plain x's. The last example is a little tricky because it all looks the same. You have x's and y's with all kinds of exponents. The important part is we want to group together the ones that are exactly the same. This is an x squared y term. The only other one that has an x squared y is this one. So together I have negative 2 of those. The other term is xy squared. In total, I have 15 of them. Although these two have the same variables, they don't match in exponents, so I have to keep them separate, and this is considered simplified. The next thing we're going to do is use exponents to reduce fractions. To do this, we're going to write it out. There are 2 x's in the numerator and 1 y. In the denominator, 1x and 1y. I'll reduce the numbers first. Since 4 goes into both 8 and 12, I'll do that first. This x will reduce, this y will reduce. And the only thing left over in the numerator is a 2x, and then in the denominator a 3. In the second example, I have 2a's and 3b's. In the denominator, 3a's and 1b. The numbers are factorable by 5. An a reduces, another a reduces, and a b. I'm left with 3 and 2 b's in the numerator. That's 3b squared. In the denominator, just a 5 and an a. Next, we're going to multiply. One thing I suggest is that you reduce the numbers first, then we'll take care of the variables. For example, 6 goes into 12 twice. I think that'll make the numbers a lot more reasonable to work with. We have 4, an x, a 2, and y squared all in the numerator, a y, a 7, and an x squared in the denominator. One of the x's cancel, one of the y's cancel, and we're left with 4 times 2 times y, or 8y, in the denominator 7 times x, or 7x. Reducing the second one, 8 goes into 16 twice. Two goes into 12 6 times. And 3 goes both into 6 and 9. Writing out the leftover parts, I have 3 a's, the number 2, and 2 b's. In the denominator, 3, a b, and an a. One of the a's cancels, one of the b's cancel. And I'm left with 2a squared b over 3. Division works the same way. If you remember, we actually multiply by the reciprocal. So I'm going to have to rewrite this problem before we even get started. Y is 5. This is going to give some good practice on order of operations. I don't have any parentheses, so I'm going to go right to exponents and evaluate those. Negative 2 squared is 4. 5 squared is 25. Next thing in order of operations is multiplication and division. I have 2 multiplications. 12 minus 100. And finally, to finish it, I have negative 88. The next one, I'm substituting 1/2 in for A and negative 1/3 in for B. According to order of operations, the exponents need to be done next. When you square a fraction, we square the numerator and the denominator. So I'll have 1 squared over 2 squared. For negative 1/3 squared, I'm going to go ahead and square the negative, which will make it positive. 1 squared over 3 squared. These will require a common denominator. The smallest I can think of that both 4 and 9 go into is 36. Now I'm making equivalent fractions to get 5/36 as the answer. Okay, try some of the problems.